Hi there! We're learning today how to solve three-dimensional problems using trigonometry rules. If we read the question together and if we have a look at the diagram that is provided in this question, a vertical pole PB, vertical, it means 90 degrees on the plane, stands at one corner of a horizontal rectangular field as shown. If AB is equal to 10, AD is equal to 5, and the angle of elevation of P from A, that's how we determine from A, of P from A, this is 22 degrees. Now, they want us to calculate in A the height of the pole, which is PB. Let's start by drawing a little sketch of the triangle, which is BAP, or we can call it PBA, as per the right angle triangle, which is B here. So in this triangle, that's my right angle, PBA or ABP. Remember when we used to name any angle using 3 letters. This is given to us, AB, as 10 meter, and what is unknown here is PB. Based on the given angle, PB is the opposite side, while 10M is the adjacent side. So this is my opposite. So PB, which is the height of the pole, is the opposite side of angle 22. Now, if the opposite is unknown and the adjacent is known, and the angle is known, we're going to use the tan rule. So the tan rule is equal to opposite over adjacent. Let's substitute in the equation. Tan 22 degrees is equal to PB over 10. Get rid of the denominator by multiplying all by 10. My denominator is 10. We get rid of it by multiplying the whole equation by 10. So we're going to end up with 10 times 10 tan 22 degrees. 10 tan 22 degrees. And this is the value of PB. Now you can use the calculator to calculate the length, and you're going to end up with 4.040262258. If you round your answer and it's in meters, because all dimensions of the lengths in this question are given to us in meters. Now, if you want to round it to 3 significant figures, so you start from the left. The first 4 is the first significant figure, 0 is the second, 4 is the third. Look at the right of the 4. So 0 is less than 5, so it's gonna the 4 is not going to go up. So the final answer as 3 significant figures is 4.04 meter. Let's go to the second part of the question, the angle of elevation of P from C. Of P from C. Like I said, always draw a little sketch of the triangle that you're going to work on. And the triangle here is going to be PBC, or we can name it as CBP, which is this one. This is my right angle triangle because the pole is vertical, is standing vertically on the plane, which is the ABCD. and the 5 meter CB is given to me in the question. So this is 5 meter, and the BP, which is my pole, which I calculated in the first part of the question, is equal to 4.04, and this is my unknown angle, which is BCP, or we can say PCB. Now, my unknown angle and the two given sides as per the angle. This is the adjacent to the unknown angle, the adjacent side of the unknown angle, which is 5 meter, and the opposite side, which is 4.04, as per the unknown angle. So, since the opposite and the adjacent are given, we're going to use again the tan rule. So, tan BCP is equal to opposite over adjacent. Let's substitute in the equation. So, tan unknown angle is equal to 4.04 over 5. Now, use the calculator to say the unknown angle is equal to tan inverse. How do you put tan inverse in the calculator? You press shift and tan, and a bracket will open, and then you write as a numerator 4.04. Use the arrow on the calculator to bring it down, and then write the 5. Get out of the fraction and don't forget to put the closing bracket, and then you press enter. So you use the calculator to calculate the tan inverse, and BCP is going to be equal to 38.94002938 degrees. And if we round it to 3 significant figures, 3 is the first significant figure, 8 is the second, 9 is the third. So you stop at 9. Look at the right. 4 is less than 5. So my 9 is not going to go up. It's going to stay as 9. So the final answer will be 38.9 degrees. Let's go to the last two parts of the question. So, the length of a diagonal of rectangle ABCD. Let's draw a little sketch of rectangle ABCD. As you know, in the rectangle, every two opposite sides are equal, and each angle in a rectangle is equal to 90 degrees. So, this is 10, which is given to me in the question. This is 5, is given to me in the question. And this is my 90 degree. Where is my diagonal? Draw the diagonal. The diagonal is that line that connects D with B or C with A. So this is my diagonal. How do I know that? Because the definition of the diagonal is a straight line joining two opposite corners of a square, rectangle, or any other straight-sided shape. Now, can you see the right angle triangle? BCD, or we call it DCB. So, the diagonal in the rectangle actually is the hypotenuse of my right angle triangle. It's the hypotenuse. How do I know? Because it is the length that is right opposite to the right angle. It is opposite. It's the length that is opposite to the right angle, which is BCD. So the opposite side to angle BCD is diagonal BD. Now, let's write the Pythagorean theorem. Before we talk about the Pythagorean theorem, so this is the vertical side of the right angle triangle, and this is the horizontal side of right angle triangle BCD. Now let's write the Pythagorean theorem, which states that hypotenuse to the power of 2 is equal to the vertical side to the power of 2 plus the horizontal side to the power of 2. Let's substitute in the equation. The hypotenuse is my unknown. The vertical side is 5 and the horizontal side is 10. So the hypotenuse to the power of 2 is equal to 5 to the power of 2 plus 10 to the power of 2. Don't use the calculator yet. We're finding only one hypotenuse, the length of the hypotenuse. So square root each side of the equation. And it will be square root of 5 to the power of 2 plus 10 to the power of 2. Now you can use the calculator to calculate this, and you will find the hypotenuse as 11.18033.989 meter. And if you round this to 3 significant figures, so 11, 1 after the decimal is the third significant figure. Look at the right of the 1. There is an 8. It's more than 5. So it's going to round my 1 to 2. It's going to take my 1 up to 2. So the final answer will be 11.2 meter. Now let's go to the last section of the question. So they want the angle of elevation of P from D. Let's draw a sketch of the triangle that I'm going to calculate the angle for, which is this triangle. It's PBD, or we can name it as DBP. Now, this is the unknown angle from D, the angle of elevation of P from D. So that's the unknown angle. This is my right angle, and the hypotenuse, this is my hypotenuse that I calculated in the previous step, which is 11.2. The hypotenuse is actually my diagonal, and this is this is the length of PB, which I calculated in the first part of the question. Okay, so the unknown angle, the known sides are actually, as per the unknown angle, is the opposite and the adjacent. So this is my adjacent as per the unknown angle, and this is the opposite as per the unknown angle, which is BDP. Now I'm going to use the tan rule to calculate the unknown angle, which is opposite over adjacent. Let's simply substitute in this formula. Tan BDP is equal to 4.04 over 11.2. Now we're going to use the tan inverse to find the unknown angle. So we're going to say BDP is equal to tan inverse 4.04 over 11.2. Use the calculator and you're going to end up with 19.86843888. And to round this to 3 significant figures, you're going to stop at 8 after the decimal. Look at the right of the 8, it's 6, and 6 is greater than 5, so it's going to bring my 8 up to 9. So the final answer will be 19.9 degrees. Before I end this video, have a look at this question. Please try to solve it on your own and watch the next video, maybe in the tomorrow or in the next coming 2 days, to figure out if your solution is correct or not. Thank you so much for watching. Please subscribe, like, and share if you find this video